Sputnik-1, was the first artificial Earth satellite. It was a 58 cm diameter polished metal sphere, with 4 external radio antennas to broadcast radio pulses. The Soviet Union launched it into an elliptical low Earth orbit on October 4, 1957. It was visible all around the Earth and its radio pulses were detectable. The surprise success precipitated the American Sputnik crisis and triggered the space race, a part of the larger Cold War. The launch ushered in new political, military, technological, and scientific developments. Sputnik itself provided scientists with valuable information. The density of the upper atmosphere could be deduced from its drag on the orbit, and the propagation of its radio signals gave information about the ionosphere. Sputnik-1 was launched during the International Geophysical Year from Site No. 1/5, at the 5th Chirotam Range, in Kazakh SSR. The satellite traveled at about 29,000 km per hour, taking 96.2 minutes to complete each orbit. It transmitted on 20.005 and 40.002 MHz, which were monitored by amateur radio operators throughout the world. The signals continued for 22 days until the transmitter batteries ran out on October 26, 1957. Sputnik-1 burned up on January 4, 1958, as it fell from orbit upon re-entering Earth's atmosphere, after traveling about 70 million km and spending 3 months in orbit. Before the launch, Satellite Construction Project, the history of the Sputnik-1 project dates back to December 17, 1954, when Sergei Korolev addressed Dmitry Ustinov, the Minister of Defense Industries, proposing the development of an artificial satellite, forwarding a report by Mikhail Tikhonravov with an overview of similar projects abroad. Tikhonravov emphasized that the launch of an orbital satellite was an inevitable stage in the development of rocket technology. On July 29, 1955, U.S. President Dwight D. Eisenhower announced through his press secretary that the United States would launch an artificial satellite during the International Geophysical Year. A week later, on August 8, the Politburo of the Communist Party of the Soviet Union approved the proposal to create an artificial satellite. On August 30, Vasily Ryabikov, the head of the State Commission on A-7 rocket test launches, held a meeting where Korolev presented calculation data for a spaceflight trajectory to the Moon. They decided to develop a 3-stage version of the A-7 rocket for satellite launches. On January 30, 1956, the Council of Ministers approved practical work on an artificial Earth-orbiting satellite. This satellite, named Object D, was planned to be completed in 1957, 58. It would have a mass of 1,000 to 1,400 kg and would carry 200 to 300 kg of scientific instruments. The first test launch of Object D was scheduled for 1957. Work on the satellite was to be divided between institutions as follows. The USSR Academy of Sciences was responsible for the general scientific leadership and research instrument supply. The Ministry of Defense Industry and its primary design bureau OKB-1 were assigned the task of building the satellite. The Ministry of Radio-Technical Industry would develop the control system, radio-technical instruments and the telemetry system. The Ministry of Shipbuilding Industry would develop gyroscope devices. The Ministry of Machine Building would develop ground launching, refueling and transportation means. The Ministry of Defense was responsible for conducting launches, under the direction of main engineer Dmitry Sergeyevich Mordasov. Preliminary design work was completed by July 1956 and the scientific tasks to be carried out by the satellite were defined. It included measuring the density of the atmosphere, its ion composition, the solar wind, magnetic fields, and cosmic rays. This data would be valuable in the creation of future artificial satellites. A system of ground stations was to be developed to collect data transmitted by the satellite, observe the satellite's orbit, and transmit commands to the satellite. Because of the limited time frame, observations were planned for only 7 to 10 days and orbit calculations were not expected to be extremely accurate. By the end of 1956 it became clear that the complexity of the ambitious design meant that Object D could not be launched in time because of difficulties creating scientific instruments and the low specific impulse produced by the completed A-7 engines. Consequently, the government rescheduled the launch for April 1958. Object D would later fly as Sputnik 3. Fearing the U.S. would launch a satellite before the USSR, OKB-1 suggested the creation and launch of the satellite in April/May 1957, before the IGY began in July 1957. The new satellite would be simple, light, and easy to construct, foregoing the complex, heavy scientific equipment in favor of a simple radio transmitter. On February 15, 1957, the Council of Ministers of the USSR approved the simple satellite, designated Object PS. This version allowed the satellite to be tracked visually by Earth-based observers while in orbit, and transmit tracking signals to ground-based receiving stations. The launch of two satellites, PS-1 and PS-2, with two ʻS7 rockets was approved, but only after successful testing of the ʻS7 launch vehicle. Launch vehicle preparation and launch site selection. The ʻS7 Semyuka was initially designed as an ICBM by OKB-1. The decision to build it was made by the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers of the USSR on May 20, 1954. The ʻS7 was also known by its GRAU designation 8K71. At the time, the ʻS7 was known to Western sources as the T-3 or M104, and Type AA Special Reconnaissance Commission selected Chirotam for the construction of a rocket proving ground. The selection was approved on February 12, 1955 by the Council of Ministers of the USSR, but the site would not be completed until 1958. Actual work on the construction of the site began on July 20 by military building units. On June 14, 1956, Sergei Korolev decided to adapt the ʻS7 rocket to the Object D, that would later be replaced by the much lighter Object PS. The first launch of an ʻS7 rocket occurred on May 15, 1957. The flight was controlled until the 98th second, but a fire in a strap-on booster led to an unintended crash 400 km from the site. 3 attempts to launch the second rocket were made on June 11, but an assembly defect prevented launch. The unsuccessful launch of the third ʻS7 rocket took place on July 12. During the flight, the rocket experienced an uncontrolled roll about its longitudinal axis and its engines were automatically shut off. The flight lasted 32 seconds, and the ʻS7 crashed 7 km from the site and exploded. The launch of the fourth rocket, on August 21 at 15:25 Moscow time, was successful. The rocket's core boosted the dummy warhead to the target altitude and velocity, re-entered the atmosphere, and broke apart at a height of 10 km after traveling 6,000 km. On August 27, TASS in the USSR issued a statement on the successful launch of a long-distance multistage ICBM. The launch of the fifth ʻS7 rocket, on September 7 was also successful, but the dummy was also destroyed on atmospheric re-entry, and hence needed a redesign to completely fulfill its military purpose. The rocket, however, was deemed suitable for satellite launches, and Korolev was able to convince the State Commission to allow the use of the next ʻS7 to launch PS-1, allowing the delay in the rocket's military exploitation to launch the PS-1 and PS-2 satellites. On September 22, a modified ʻS7 rocket, named Sputnik and indexed as 8K71PS, arrived at the proving ground and preparations for the launch of PS-1 began. Compared to the military ʻS7 test vehicles, the mass of 8K71PS was reduced from 280 tons to 272 tons. Its length with PS-1 was 29.167 meters and the thrust at liftoff was 3.90 mn. Observation complex. The measurement complex at the proving ground for monitoring the launch vehicle from its launch was completed prior to the first ʻS7 rocket test launches in December 1956. It consisted of 6 static stations, IP-1 through IP-6, with IP-1 situated at a distance of 1 km from the launch pad. The main monitoring devices of these stations were telemetry and trajectory measurement stations, TRAL, developed by OKB-1. They received and monitored data from the TRAL system transponders mounted on the ʻS7 rocket's core stage, which provided telemetric data about Sputnik 1's launch vehicle. The data was useful even after the satellite's separation from the second stage of the rocket. Sputnik 1's location was calculated from the data on the second stage's location using nomograms developed by P. E. Eliasberg. An additional observation complex, established to track the satellite after its separation from the rocket, was completed by a group led by Colonel U. A. Mozharin in accordance with the General Staff Directive of May 8, 1957. It was called the Command Measurement Complex and consisted of the Coordination Center and NII-4 by the Ministry of Defense of the USSR and 7 ground tracking stations, situated along the line of the satellite's ground track. They were NIP-1, NIP-2, NIP-3, NIP-4, NIP-5, NIP-6 and NIP-7. The complex had a communication channel with a launch pad. Stations were equipped with radar, optical instruments, and communication systems. PS-1 was not designed to be controlled, it could only be observed. Data from stations were transmitted by telegraphs into NII-4 where ballistics specialists calculated orbital parameters. The complex became an early prototype of the Soviet Mission Control Center. In the West, the satellite was tracked by amateur radio operators, and the booster rocket was located and tracked by the Loveal telescope at the Jodrell Bank Observatory. The Newbrook Observatory was the first facility in North America to photograph Sputnik 1. Design. The chief constructor of Sputnik 1 at OKB-1 was M.S. Khomyakov. The satellite was a 585 mm diameter sphere, assembled from 2 hemispheres which were hermetically sealed using O-rings and connected using 36 bolts, and had a mass of 83.6 kilograms. The hemispheres were 2 ohm thick, and were covered with a highly polished 1 ohm thick heat shield made of aluminium magnesium titanium AMG6T alloy. The satellite carried 2 pairs of antennas designed by the Antenna Laboratory of OKB-1 led by M.V. Kryushkin. Each antenna was made up of 2 whip-like parts, 2.4 and 2.9 meters in length, and had an almost spherical radiation pattern, so that the satellite beeps were transmitted with equal power in all directions, making reception of the transmitted signal independent of the satellite's rotation. The power supply, with a mass of 51 kg, was in the shape of an octagonal nut with a radio transmitter in its hull. It consisted of 3 silver-zinc batteries, developed at the All-Union Research Institute of Current Sources under the leadership of N.S. Lidorenko. 2 of these batteries powered the radio transmitter and 1 powered the temperature regulation system. The batteries had an expected lifetime of 2 weeks, and operated for 22 days. The power supply was turned on automatically at the moment of the satellite's separation from the second stage of the rocket. The satellite had a 1-watt, 3.5 kg radio transmitting unit inside, developed by V.I. Lapo from NII 885, that worked on 2 frequencies, 20.005 and 40.002 MHz. Signals on the first frequency were transmitted in 0.3 seconds pulses, with pauses of the same duration filled by pulses on the second frequency. Analysis of the radio signals was used to gather information about the electron density of the ionosphere. Temperature and pressure were encoded in the duration of radio beeps. The temperature regulation system contained a fan, a dual thermal switch, and a control thermal switch. If the temperature inside the satellite exceeded 36 °C the fan was turned on, and when it fell below 20 °C the fan was turned off by the dual thermal switch. If the temperature exceeded 50 °C or fell below 0 °C, another control thermal switch was activated, changing the duration of the radio signal pulses. Sputnik 1 was filled with dry nitrogen, pressurized to 1.3 atmospheres. The satellite had a barometric switch, activated if the pressure inside the satellite fell below 130 kilopascals, which would have indicated failure of the pressure vessel or puncture by a meteor, and would have changed the duration of radio signal impulse. While attached to the rocket, Sputnik 1 was protected by a cone-shaped payload fairing, with a height of 80 cm. The fairing separated from both Sputnik 1 and the spent R-7 second stage at the same time as the satellite was ejected. Tests of the satellite were conducted at OKB-1 under the leadership of O.G. Ivanovsky. Launch and mission. The control system of the Sputnik rocket was adjusted to an intended orbit of 223 km by 1450 km, with an orbital period of 101.5 minutes. The trajectory was calculated earlier by Georgy Grichko, using the USSR Academy of Sciences mainframe computer. The Sputnik rocket was launched on October 4, 1957 at 19:28 and 34 seconds UTC from site number 1 at NIIP-5. Telemetry indicated the side boosters separated 116 seconds into the flight and the core stage engine shut down 295.4 seconds into the flight. At shutdown, the 7.5-ton core stage with PS-1 attached had attained an altitude of 223 km above sea level, a velocity of 7,780 ams and velocity vector inclination to the local horizon of 0 degrees 24 minutes. This resulted in an initial orbit of 223 km by 950 km, with an apogee approximately 500 km lower than intended, and an inclination of 65.1 degrees and a period of 96.2 minutes, 19.9 seconds after engine cutoff. PS-1 separated from the second stage and the satellite's transmitter was activated. These signals were detected at the IP-1 station by Junior Engineer Lieutenant V.G. Borisov, where reception of Sputnik's beep-beep-beep tones confirmed the satellite's successful deployment. Reception lasted for 2 minutes, until PS-1 fell below the horizon. The TRAL telemetry system on the U-7 core stage continued to transmit and was detected on its second orbit. The designers, engineers and technicians who developed the rocket and satellite watched the launch from the range. After the launch they drove to the mobile radio station to listen for signals from the satellite. They waited about 90 minutes to ensure that the satellite had made one orbit and was transmitting, before Kirillaev called Soviet Premier Nikita Khrushchev. On the first orbit the Telegraph Agency of the Soviet Union transmitted, as result of great, intense work of scientific institutes and design bureaus, the first artificial Earth satellite has been built. The U-7 core stage, with a mass of 7.5 tons and a length of 26 meters, also reached Earth orbit and was visible from the ground at night as a first-magnitude object following the satellite. Deployable reflective panels were placed on the booster in order to increase its visibility for tracking. The satellite itself, a small, highly polished sphere, was barely visible at sixth magnitude, and thus more difficult to follow optically. A third object, the payload fairing, also achieved orbit. The core stage of the U-7 remained in orbit for 2 months until December 2, 1957, while Sputnik 1 orbited until January 4, 1958, having completed 1,440 orbits of the Earth. Reaction: further information, Sputnik crisis. Our movies and television programs in the 50s were full of the idea of going into space. What came as a surprise was that it was the Soviet Union that launched the first satellite. It is hard to recall the atmosphere of the time. The Soviets provided details of Sputnik before the launch, but few outside the Soviet Union noticed. After reviewing information publicly available before the launch, Willy Ley wrote in 1958, "If somebody tells me that he has the rockets to shoot a Euro, which we know from other sources, anyway a Euro, and tells me what he will shoot, how he will shoot it, and in general says virtually everything except for the precise date a Euro, well, what should I feel like if I'm surprised when the man shoots?" Teams of visual observers at 150 stations in the United States and other countries were alerted during the night to watch for the Soviet sphere at dawn and during the evening twilight. They had been organized in Project Moonwatch to sight the satellite through binoculars or telescopes as it passed overhead. The USSR asked radio amateurs and commercial stations to record the sound of the satellite on magnetic tape. News reports at the time pointed out that anyone possessing a shortwave receiver can hear the new Russian Earth satellite as it hurtles over his area of the globe. Directions, provided by the American Radio Relay League, were to tune in 20 megacycles sharply, by the time signals, given on that frequency. Then tune to slightly higher frequencies. The beep sound of the satellite can be heard each time it rounds the globe. The first recording of Sputnik 1's signal was made by RCA engineers near Riverhead, Long Island. They then drove the tape recording into Manhattan for broadcast to the public over NBC radio. However, as Sputnik rose higher over the East Coast, its signal was picked up by ham station W2AE, the ham radio station of Columbia University. Students working in the university's FM station, WKCR, made a tape of this, and were the first to rebroadcast the Sputnik-1 signal to the American public. At first the Soviet Union agreed to use equipment compatible with that of the United States, but later announced the lower frequencies. The White House declined to comment on military aspects of the launch, but said it did not come as a surprise. On October 5 the Naval Research Laboratory announced it had recorded 4 crossings of Sputnik-1 over the United States. The USAF Cambridge Research Center collaborated with Bendix Friars, Westinghouse Broadcasting Company, Smithsonian Astrophysical Observatory, and MIT, to obtain a motion picture of the rocket body of Sputnik-1 crossing the pre-dawn sky of Baltimore, broadcast on October 12 by WBZ-TV in Boston. U.S. President Eisenhower obtained photographs of the Soviet facilities from Lockheed U-2 flights conducted since 1956. The USSR's launch of Sputnik spurred the United States to create the Advanced Research Projects Agency in February 1958 to regain a technological lead. 1957 October 4 the USSR launches Sputnik, the first artificial Earth satellite. 1958 February 7 in response to the launch of Sputnik, the U.S. Department of Defense issues Directive 5105.15 establishing the Advanced Research Projects Agency. The organization united some of America's most brilliant people, who developed the United States' first successful satellite in 18 months. Several years later ARPA began to focus on computer networking and communications technology. In Britain the media and population initially reacted with a mixture of fear for the future, but also amazement about humankind's progress. Many newspapers and magazines heralded the arrival of the space age. However, when the Soviet Union launched a second craft containing the ๊sputnják, the media narrative returned to one of anti-communism and many people sent protests to the Russian embassy and the RSPCA. Propaganda. Sputnik-1 was not immediately used by Soviet propaganda. The Soviets had kept quiet about their earlier accomplishments in rocketry, fearing that it would lead to secrets being revealed and failures being exploited by the West. When the Soviets began using Sputnik in their propaganda, they emphasized pride in the achievement of Soviet technology, arguing that it demonstrated the Soviets' superiority over the West. People were encouraged to listen to Sputnik's signals on the radio and to look out for Sputnik in the night sky. While Sputnik itself had been highly polished, its small size made it barely visible to the naked eye. What most watchers actually saw was the much more visible 26-meter core stage of the R-7. Shortly after the launch of PS-1, Khrushchev pressed Korolev to launch another satellite in time for the 40th anniversary of the October Revolution on November 7, 1957. The launch of Sputnik surprised the American public and shattered the perception of the United States as the technological superpower and the Soviet Union as a backward country. Privately, however, the CIA and President Dwight D. Eisenhower were aware of progress being made by the Soviets on Sputnik from secret spy-plane imagery. Together with the Jet Propulsion Laboratory, ABMA built Explorer 1 and launched it on January 31, 1958. Before work was completed, however, the Soviet Union launched a second satellite, Sputnik 2, on November 3, 1957. Meanwhile, the televised failure of Vanguard TV3 on December 6, 1957 deepened American dismay over the country's position in the space race. The Americans took a more aggressive stance in the emerging space race, resulting in an emphasis on science and technological research and reforms in many areas from the military to education systems. The federal government began investing in science, engineering and mathematics at all levels of education. An advanced research group was assembled for military purposes. These research groups developed weapons such as ICBMs and missile defense systems, as well as spy satellites for the U.S. Replicas, A model of Sputnik 1 was given to the United Nations and now decorates the entry hall of its headquarters in New York City. Other replicas are on display at the Smithsonian's National Air and Space Museum in Washington, D.C., at the Kansas Cosmosphere and Space Center in Hutchinson, Kansas, at the Science Museum, London, at the World Museum in Liverpool, and hanging in the Noble Planetarium at the Fort Worth Museum of Science and History in Fort Worth, Texas. 3 1/3 scale student-built replicas of Sputnik 1 were deployed from the Mir space station between 1997 and 1999. The first, named Sputnik 40 to commemorate the 40th anniversary of the launch of Sputnik 1, was deployed in November 1997. Sputnik 41 was launched a year later, and Sputnik 99 was deployed in February 1999. A fourth replica was launched but never deployed, and was destroyed when Mir was deorbited. A full-scale model of Sputnik 1 is on display at the California Science Center in Los Angeles, California. Impact. On Friday, October 4, 1957, the Soviets had orbited the world's first artificial satellite. Anyone who doubted its existence could walk into the backyard just after sunset and see it. Initially, U.S. President Eisenhower was not surprised by Sputnik. He had been forewarned of the U-7's capabilities by information derived from U-2 spy plane overflight photos as well as signals and telemetry intercepts. The Eisenhower administration's first response was low-key and almost dismissive. Eisenhower was even pleased that the USSR, not the USA, would be the first to test the waters of the still uncertain legal status of orbital satellite overflights. Eisenhower had suffered the Soviet protests and shootdowns of Project Gentrix balloons and was concerned about the probability of a U-2 being shot down. In order to set a precedent for freedom of space before the launch of America's secret WS-117L spy satellites, the USA had launched Project Vanguard as its own civilian satellite entry for the International Geophysical Year. Eisenhower greatly underestimated the reaction of the American public, which was shocked by the launch of Sputnik 1 and by the televised failure of the Vanguard Test Vehicle 3 launch attempt. The sense of fear was inflamed by Democratic politicians and professional Cold Warriors, which portrayed the United States as woefully behind. One of the many books which suddenly appeared for the lay audience noted 7 points of impact upon the nation. Those points of impact were: Western leadership, Western strategy and tactics, missile production, applied research, basic research, education, and democratic culture. The USA soon had a number of successful satellites, including Explorer 1, Project SCORE, and Courier 1B. However, public reaction to the Sputnik crisis led to the creation of the Advanced Research Projects Agency, NASA, and an increase in U.S. government spending on scientific research and education. Not only did the launch of Sputnik spur America to action in the space race, it also led directly to the creation of NASA. Through the Space Act Bill, Sputnik also contributed directly to advancement in science and technology. This came about when President Eisenhower enacted a bill called the National Defense Education Act. This bill encouraged students to go to college and study math and science. The students' tuition fees would be paid for. This led to a new emphasis on science and technology in American schools. Sputnik also created building blocks which probably led to the general establishment of the way science is conducted in the United States today. One consequence of the Sputnik shock was the perception of a missile gap. This was to become a dominant issue in the 1960 presidential campaign. One irony of the Sputnik event was the initially low-key response of the Soviet Union. The Communist Party newspaper Pravda only printed a few paragraphs about Sputnik 1 on October 4. In the days following the world's startled response, the Soviets started celebrating their great accomplishment. Sputnik also inspired a generation of engineers and scientists. Harrison Storms, the North American designer who was responsible for the X-15 rocket plane, and went on to head the effort to design the Apollo Command Service Module and Saturn V launch vehicle's second stage, was moved by the launch of Sputnik to think of space as being the next step for America. Astronauts Alan Shepard, who was the first American in space, and Deke Slayton later wrote of how the sight of Sputnik I passing overhead inspired them to their new careers. Homer Hickham's memoir Rocket Boys and the movie October Sky tell the story of how a coal miner's son, inspired by Sputnik, started building rockets in the mining town where he lived. The launch of Sputnik 1 inspired U.S. writer Herb Cohen to coin the term beatnik in an article about the Beat generation in the San Francisco Chronicle on April 2, 1958. Backup units. A Sputnik 1 backup unit is on display at the personal library of Jay Walker, an Internet entrepreneur. In 2003 a backup unit of Sputnik 1 called Model PS1 failed to sell on eBay. It was offered while still on display in a science institute near Kiev. It is estimated that between 4 and 20 models were made for testing and as replicas. What is thought to be a backup of Sputnik 1 now hangs at the Museum of Flight in Seattle, Washington. The craft was manufactured by the Soviet Academy of Sciences and has battery acid remnants on the inside walls of the spherical shell, as well as fittings for the various components, suggesting that it was more than just a model. See also: ILLIACIA first computer to calculate the orbit of Sputnik I, Defense Advanced Research Projects Agency, Sergei Korolev chief designer of Sputnik 1, Donald B. Gillies one of the first to calculate the Sputnik 1 orbit, Kerem Kerimov one of the lead architects behind Sputnik 1, Sputnik Crisis the American reaction to the success of the Sputnik program, Space Race the competition between the Soviet Union and the United States for supremacy in space exploration, timeline of Russian inventions and technology records, Homer Hickham's classic memoir Rocket Boys, and the film October Sky tell how a coal miner's son was so inspired by Sputnik, he began to build rockets to the surprise and consternation of his hometown. It is an example of how a generation of American youth became enamored with space and science because of Sputnik 1. Notes. Bibliography, Bilstein, Roger E. Stages to Saturn: A Technological History of the Apollo-Saturn Launch Vehicles, Washington, D.C., National Aeronautics and Space Administration, NASA SP 4206, Brzezinski, Matthew B. Red Moon Rising, New York, Henry Holt & Company, ISBN 978-0-8050-8147-3, Burroughs, William E., By Any Means Necessary, Farrar, Straus and Giroux, New York, ISBN 0-374-11747-0. Cox, Donald and Stocco, Michael, Spacepower: What It Means to You, Philadelphia, Pennsylvania, The John C. Winston Company, Dixon, Paul, Sputnik, The Shock of the Century, Walker and Company, ISBN 978-0-8027-1365-0, Devine, Robert A. The Sputnik Challenge, New York and Oxford, Oxford University Press, ISBN 0-19-505008-8, Dudney, Robert S., When Sputnik Shocked the World. Air Force Magazine 90, 2 €43. Retrieved October 2, 2007. Gray, Mike, Angle of Attack. Harrison Storms and the Race to the Moon, New York, W. W. Norton and Company, ISBN 0-393-01892-X. Green, Constance McLaughlin, and Lomax, Milton Vanguard: A History, Washington, D.C., National Aeronautics and Space Administration, NASA SP 4202. Harford, James Korolev, New York. John Wiley & Sons, Incorporated, ISBN 0-471-14853-9. Isaakov, Vladimir. Sputnik at 50, An Improvised Triumph. USA Today. Associated Press. Retrieved December 3, 2010. Lashma, Paul, Spy Flights of the Cold War, Annapolis, Maryland, United States Naval Institute Press, ISBN 1505078372. Loviel, Sir Bernard, The Story of Jodrell Bank, New York, Harper & Row, Publishers, Library of Congress Card No. 68-17043, McDougall, Walter A. The Heavens and the Earth, New York. Basic Books, Publishers, ISBN 0-465-02887-X. Mieczkowski, Jank. Eisenhower's Sputnik Moment, The Race for Space and World Prestige. The American Response, Peebles, Curtis. The Corona Project, Annapolis, Maryland. The United States Naval Institute Press, ISBN 1-55750-688-4. Peebles, Curtis. The Moby Dick Project, Washington, The Smithsonian Institution Press, ISBN 1-56098-025-7. Peebles, Curtis. Shadow Flight, Novato, California. The Presidio Press, Incorporated, ISBN 0-89141-700-1. Prados, John. The Soviet Estimate, New York, The Dial Press, ISBN 0-385-27211-1. Shepard, Alan and Slayton, Deke, Moonshot, Atlanta, Georgia, Turner Publishing, Incorporated, ISBN 1-57036-167-3, Siddiqui, Asif A., Sputnik and the Soviet Space Challenge, Gainesville, FL. The University of Florida Press, ISBN 0-8130-2627-X. Swenson, L., J.R., Grimwood, J.M. Alexander, C.C. This New Ocean, A History of Project Mercury, Washington, D.C. National Aeronautics and Space Administration, Library of Congress Card No. 66-62424, Zaliger, Stephen J. The Kremlin's Nuclear Sword, Washington. The Smithsonian Institution Press, ISBN 1-58834-007-4. External links, authentic recordings of the signal, recording from Washington, D.C., recording from German ham operator, recording from Czechoslovakia. This Russian page contains signals which are probably the faster pulsations from Sputnik 2, world's first satellite, and the international community's response. A NASA history website on Sputnik contains this commonly copied recording, which is some pulse duration modulated signal of an unknown spacecraft. NASA full Sputnik recording, history, by Don Mitchell, by Asif Siddiqui, by Anatoly Zak. Other sites of interest, Sputnik 1 diary, primary sources, Soviet documents, newspaper accounts on ham radio operators, documents related to Sputnik and the space race, Dwight D. Eisenhower Presidential Library, miscellaneous, a film clip New Moon. Red's launch first space satellite, 195,707 inches is available for free download at the Internet Archive. More, Timeline of Space Exploration and Sputnik Diagram by Newsweek, an interview with Sir Arthur C. Clarke on Sputnik, NASA's 50th anniversary of the space age and Sputnik interactive media, Sputnik program page by NASA's Solar System Exploration, Sputnik original reports from the Times, 1958 video newsreel of Russian exhibition of Sputnik 1, 50th anniversary of the Earth's first artificial satellite launch. RIA Novosti video, NASA on Sputnik 1, a joint Russian project of Ground Microprocessing Information Systems SRC Planeta, and Space Monitoring Information Support Laboratory dedicated to the 40th anniversary of Sputnik 1, Top 10 Sputniks.